How to convert a decimal number to a binary number. In this tutorial, we will describe how to convert a decimal number to a binary number. For example, let us convert the following. Alright, so we're going to take the value 205, which is represented in decimal, and we're going to convert that to its binary representation. For this example, our expected value would be 11001101, and of course that's represented in binary. To begin the process, and since we're using the binary number system, we'll be dividing 205 by the value 2. One thing to keep in mind when we actually perform this computation is to keep in mind that we're going to pay attention to the remainder. Okay, so if there is a remainder, then we will actually, it would produce an output of 1. If the division produces no remainder, then it would be a value of 0. All right, let's compute. So we start off, we have, let's see, 205 divided by 2. And that gives us a value. Just want to get this right. 205 divided by 2 will be a value of 102.5. And just because we have a decimal point, that says that we have a remainder. So let's make a note up here. We keep track of the remainder. Okay, so that goes in here. 2 goes into 205 102.5 times, but we keep the integer portion right here. And then we said that if we have a remainder, then it's going to be a value of 1. All right. So next we take the value 102 and divide 2 into it. So 2 divides into 102. Let's compute that. 102 divided by 2 equals 51. And in this case here, there's no remainder, so it goes in there evenly. So this is 51, and since there's no remainder, we have the value 0. So next, the value of 51 is going to be divided by 2. We continue. So 2 divides into 51. 51 divided by 2. It's a value 25.5. So that indicates that in this case we have a remainder. So we go ahead and put the integer portion here, 25, and then we'll represent that we have a remainder, which would be the value 1. All right, we continue. We'd go ahead and say 2 divides into 25. And so 25 divided by 2, we get a value of 12.5. So this indicates that we have a remainder. So we put the integer portion here, 12, and then we'll indicate out here that we have a remainder. All right, so let's go ahead and take what we have next is the value 12. So we divide 2 into 12. That should be 6 times. And it goes in there evenly, so 6 is here, and that indicates that we do not have a remainder. So 0 goes here. So next we take the next number, is 6, and we divide by 2, and of course that goes in there 3 times, and it goes in there evenly, and there's no remainder, so this indicates that we have a 0 here. Okay, So now the next value to divide 2 into is 3. So 2 divides into 3, and it should be 1.5. 1.5. So this indicates that 2 go into 3 one time, and there is a remainder. And since there's a remainder, this value is 1. And we still continue. The next value to divide it into is 2 divided into 1. So 2 divided into 1, actually it's 0.5. And what that indicates that 2 divides into 1 0 times. And there is also a remainder. So 1 goes here. Now, since we have the 0 here, this is our stopping point here. And what we can do is start to convert. This represents position 7. This is 6. This is 5, 4, 3, 2, 1, and 0. So we'll take the 1 up here. So it's 1, 1, 0, 0, 1, 1, 0, 1. And of course, this is a binary representation, and it matches exactly our expected value. And this is what we wanted to show. Next, let us perform another decimal to binary conversion. This time we will convert numbers with a decimal point. Okay, once again, we have a computation. We want to convert a decimal number that's represented in decimal, 175.75, and its binary representation is 10101111.11. Now we have to do this a little bit differently here. So since this is a decimal, we're going to take the integer portion and actually perform the computation that we did in the previous example. So 175 would be divided by 2 until we reach a point where we reach 0. But when we get to the decimal part, the 0.75, we have to do the opposite of division, which is multiplication. You'll see in the computation. So let's begin. So we start off, we have 2 divide into 175. And let's see what we have. 175 divided by 2 is this value, 87.5. And what this says, 2 goes into 175 87 times. And since there's a decimal point, we have a remainder. So let's kind of indicate our remainder guy. So we have something out here. Okay, so we have a remainder. So we said that if we have a remainder, its value is going to be 1. All right, so let's go ahead and divide the next number. So we have 87 divided by 2. And so 87 divided by 2 is 43.5. And so this says that 2 goes into 87 43 times, and the 0.5 indicates that we have a remainder. And we said that if we have a remainder, then we need to indicate a 1 here. All right, so the next number is 43. And we're going to divide 2 into 43. See what we get. Divided by 2. We have a value of 21.5. So it says that 2 goes into 43 21 times. And so since we have a decimal point there, that indicates that we have a remainder here. So we want to indicate that here. And so that's a 1. So now we continue. We have the next number is 21, and we divide that by 2. Let's see, 21 divided by 2, and we get the value 10.5. And that indicates that 2 goes into 21 10 times, and there's a remainder. So let's indicate that in the remainders column. All right, so let's continue. We're going to take the value 10 and divide 2 into 10. And of course, that goes in there 5 times. So 5 times evenly. And since there's no remainder, we have a value 0 here. So next we take 5 and divide 2 into 5. And so we get the value 2.5. And that indicates that 2 goes into 5 2 times, and as a remainder. So this is a value of 1. And we continue. We have next is the value 2 will be divided by 2. And of course that goes in there one time evenly. And so this indicates that we have no remainder. So that's a 0. And we continue. So 2 will divide into 1. And of course that will be the value 0.5. So to indicate 2 goes into 1 0 time, which is a true statement. But we still have a remainder. So 1 goes here. So what we want to look at here, because I'm going to have to erase this, so we have this one here is in position 7. That's in position 6. This is in position 5, position 4, position 3, position 2, position 1, and position 0. So that means that we have our integer portion, which is 1, 0, 1, 0, 1, 1, 1, 1, and 2. All right. So let's make room here. I want to show the... Actually, I can use it here. So what we'll do is look at the 0.75. We said that, all right, so the integer portion, we did the normal process, divide 175 divided by 2. So when we get to the decimal part of it, we have to do the reverse of division, which is going to be multiplication. So we start off, we have 175.75, so we just take off the decimal portion. We have 0.75 times 2. And what that comes out to be, we got 0.75 times 2 comes to be 1.5. Now this can also be indicated as saying 1 plus 0.5. And what we do now is take this portion of it and compute it by 2. So I'm going to say 0.5 times 2, and we get the value 1. Now this can also be represented as 1 plus 0. And since we have the value 0, that's our stopping point right there. So we need to go no further than that. So the actual digits that we're looking for is right here. And what this is saying, so now we have the 0.75 in decimal is equivalent to 0.11 in binary. So we add these two together, and this comes out to be exactly what we're looking for. Should be 1 0 1 0 1 1 1 1 0.11, and it matches our expected value. And this is what we wanted to show. This puts us in a position for my next tutorial, where we describe how to convert from decimal numbers to hexadecimal numbers. I hope this tutorial was helpful. If you find this tutorial to be helpful, please subscribe to my YouTube channel. Also feel free to join us here at the Computing Sector. There will be more videos and tutorials coming soon. Thanks.